In this video, we're going to take a look at battery fundamentals and service precautions that we should be looking at when we're dealing with batteries and just general overall safety precautions. Number one is when a battery is charging or we're working around batteries, we should always be wearing protective clothing, safety glasses especially, a shield, making sure that we know what we're doing before we start to test a battery or when we're working around batteries. To short across a battery can cause a battery to explode. So being careful when we're checking the electrolyte levels in the batteries, making sure that again that we don't breathe the vapors and we don't splash it on our clothing, because it is hydrochloric acid or sulfuric acid, and that sulfuric acid can cause burns. Again, the other thing is if we short across the battery post, the battery can explode. The battery can explode as we're charging it. So really pay a lot of attention to what's going on when we're working around batteries. So taking a look at a very basic battery. All the newer style batteries have a little eye that we can tell what the percent of battery charge is. So for instance, if the eye has a green dot, that means that the percentage of charge is 75% above. If it's a dark black, then it means it's below 75%, and if it's clear, the electrolyte level is low. Having a green and a black dot is not a big issue. If we see a clear dot, it is, because at that point the cells could be exposed and we could get a spark, and that could cause an explosion of a battery. Anytime we have a clear dot, and these are our maintenance-free batteries, we can't do anything with them, so that battery has to be removed from service and replaced. Now, we're going to deal with two different types of batteries: maintenance free, which is this style here where it has an eye, or the maintenance style battery where we have covers on them where we can go in and we can check the electrolyte level and we can check the specific gravity of a battery. So number one, when we are removing a battery to do some testing, we always want to make sure that we disconnect batteries. Most of our systems are set up that we have more than one battery set up. We want to make sure that we disconnect those batteries before we test them, because we want to test each individual battery. We don't want to check the battery as a group. How do we remove and what do we remove? We always remove the ground first, not the negative. Always the ground, because we may have some batteries or systems that are positive ground. So we always want to remove the ground cable first, then we can remove the positive cable. Now most of our systems again are set up so that battery is negative ground and positive power. So again, be very careful when we're removing the battery terminals from the post. Don't pry them off, because we can break the post, we can crack the case. So we want to make sure that nothing can touch metal that can short out a battery, and then that's why we always remove our ground side first. Having wrenches in our coverall pockets is another problem. As we lean over, that wrench can fall out and short across a battery and cause that battery to explode. How does a maintenance battery set up? Well, we have our positive post and we have our negative post, and if they're not marked, how do we tell the difference? Positive post is always larger in diameter than the negative post. We have our vent caps. Anytime we're working on a battery, those vent caps should be on the battery so that we don't drop something in there or we don't spill the acid. Anytime that we're charging a battery, the vent caps should be on. Now, taking a look at different styles of batteries, some have top posts, some have side posts, making sure that our connections are tight And again, in a case like this, we have a negative ground system. We're going to remove the negative post or negative cable first. Once that's been disconnected, then we can remove the positive post without or cable without shorting out the battery and creating problems. So let's take a look at how a battery is constructed. So batteries are constructed of negative and positive plates. So depending on the style of battery, for instance a maintenance or a maintenance-free battery, the positive plates are made out of different material. So our positive plate is made out of lead peroxide. So we'll have a shell that's this lead peroxide paste is attached to. And then we're going to have a number of positive plates within each cell. Now these positive plate groups again determine what the capacity of our battery is. All these positive plates are hooked up in parallel, and all our negative plates are hooked up in parallel. Now there's a couple things that we can increase the capacity of our battery by doing, and we're going to take a look at what different capacities we have a little later on. But by adding mass or making the plates thicker will allow the battery to produce current for a longer period of time. By adding plate area or making them longer or adding more plates, we can increase the ability to produce higher current for shorter periods of time. So inside our battery cell, and we'll talk about for instance a 12-volt battery to start with. The 12-volt battery is going to have 6 cells. Each cell is capable of producing roughly 2.1 volts. Now inside each of these cells we have our positive plates here, and we have a strap that connects all our positive plates together, so this is in parallel. And in between each positive plate we'll have a negative plate. Now the positive plates are the active plates, so to ensure that all of the active plates work properly, we're going to have a negative plate on each side of that positive plate. So we'll end up with one more negative plate in a cell than we will a positive plate, because we need that plate to be active on through both sides. And you'll see why as we go through. Now, in order to make sure that the negative and positive plates don't touch each other, which would cause them to short out, we have a separator. And separators are usually just some type of a cloth that fits over the plate just to keep them separated. So when we put our negative and positive plates together with our separators in the middle so that they can't touch, then we have an active cell. And taking a look at a battery that, again, we have our negative plate strap and they're hooked up in parallel. And then what we're going to do is we're going to take and we're going to hook up all of these cells in series. By hooking each cell up in series, each cell is capable of 2.1 volts. If we have 6 cells, that gives us 12.6 volts per battery. Now, if we are dealing with a 24-volt battery, we just have 6 more cells that are hooked up in series to give us 24 volts. Now, how the terminals or side posts are attached depends on the manufacturer. So they can be just a lead post. And this is why we have to be careful when we're taking battery connections off, because we can bust the post and we may not even know, and that could cause a problem where we could end up with a short inside the case that can cause a battery to explode. So each cell is separated by a plastic barrier, and we have to join again how series circuits are set up. So if we start from the negative side, our positive will be hooked to the negative of the next cell. the positive of that cell will be hooked to the negative of the next cell, and this adds to our voltage. So that's a series circuit set up inside each battery cell. So taking a look at, this is a battery again, each cell is capable of producing roughly 2.1 volts. So if we started our negative, our positive is hooked to the negative of the next cell, positive to the negative of the next cell, and so on and so on, and our last positive goes to our battery post. Now, one of the things to remember when we're checking voltage with a meter, what does a meter tell us? Well, a meter tells us what's the potential difference between 2 points. And what we're checking here is the negative and positive, and our potential difference between those 2 points is 12.6 volts. So what happens when we have a problem internally? So again, if we add more mass or more area, again, we can increase the capacity of this battery, but not the voltage. We're not increasing the voltage, we're just increasing the capacity that this battery can put out. So you'll see batteries that have very little capacity. Let's just say, for instance, 500 cold cranking amps or 1250 or 1200 cold cranking amps. So it's the makeup of the battery that determines what the CCA of that rating of the battery is. So really, the heavier the battery usually means the more plates we have in there, the more capacity it can handle. So how does the battery work? So if we take a look at the battery itself, so we have a positive plate and a negative plate. And in order for this to work, we need some type of an electrolyte, something that conducts current through a battery. And what we have is sulfuric acid and water, 36% sulfuric acid, 64% water. Now, our plates are made up of different material. I told you the positive plate was lead peroxide, which is PbO2. And our negative plate is lead, but it has to be covered with something. And this material has to be porous to allow current transfer between the negative and positive, or ion transfer between the negative and positive plates. So our negative plate is made out of spongy lead. So what happens when we go and we discharge a battery? So we hook up a light to it. What happens? Well, we get current flow. We're completing the circuit between our negative and positive, and what happens is we get transfer internally inside. So what happens is to our H2SO4 is the SO4 will actually leave the solution, the electrolyte, and it will attach to both the negative and the positive plate. What happens then is we get our plates turning into PbSO4, which is lead sulfate. Both negative and positive plates end up with PbSO4. Now, if we, for any reason, leave this discharge for a long time, that sulfate will start to crystallize. Now, as it crystallizes, it makes that plate ineffective because now we can't have flow between those plates because part of it is partially being blocked. So when we go to charge a battery, what happens internally? Well, as we have an alternator and it charges it, now our current flows from negative to positive. We have an alternator in the middle. Now we have to have a complete circuit in order for this to happen. So as we're pushing current into the positive of the battery, it's forcing the SO4 off of the plate and back into solution. Same thing with the negative plate. So now our H2SO4 solution is increasing and our H2O is decreasing. So this is why in the wintertime, if we have a partially discharged battery, it'll freeze because our solution, our concentrate, is more water than it is H2SO4, and again, it'll freeze at a higher temperature. So we always want to make sure that we either put our batteries on charge over the winter time or remove them from a machine and put them in a place where they won't freeze. Because if they freeze, they'll distort, and if they distort, they can distort the cells, and it can cause an internal short. So anytime we suspect that we have a frozen battery, we should be replacing that battery. We should never try and charge it. Rule of thumb is if it's frozen, replace it. Now there's different types of groups of batteries, and again for us the different types of groups don't matter. We're going to replace a battery with the group that's specified in manufacturer specifications for that machine. Again, it can be a 12-volt battery, or it can be just a large 6-volt battery. How do we rate batteries? Well, a couple of things. Reserve capacity. So the reserve capacity of the battery is the battery's ability to supply power when the charging system fails to keep the voltage above 1.7 volts per cell. The amp hour rating is keeping it above 1.7 volts per cell. What we deal with most is cold cranking amps. So this is the amperage at which the battery can deliver current at minus 18 degrees for 30 seconds to maintain terminal voltage above 1.2 volts per cell. Now 1.2 volts per cell, we don't test each individual cell, we test the battery as a unit, and 1.2 volts per cell would be 7.2 volts. The other one is cranking amps, and it's the cranking amp of a battery is the amperage a battery can deliver at 0 degrees for 30 seconds and maintain a terminal voltage of 1.2 volts per cell. But again, what we deal with is the CCA rating of a battery, and this is important to remember. This one is because as we're testing a battery, you'll see why we need to know what the CCA rating of a battery is. Now, open circuit voltage is something that gives us, it doesn't tell us how good the battery is. There's nothing that can tell us how long a battery is going to be good for. But having open circuit voltage by taking a meter and putting it across the negative positive volts posts will give us an indication of what the state of the charge of the battery is. As you can see from this graph, if we have 12.6 volts, we can pretty well assume that it's 100% charged. Again, that doesn't mean that that battery is good. It just means that our open circuit voltage is 12.6 volts. We could have probably 3/4 of the plates gone, and we may still get 12.6 volts across there, but the battery may not start a vehicle. So as our open circuit voltage drops, our state of charge drops. And what happens is when we start getting down to 11.6 volts, our state of charge is not very good and needs to be recharged. Now, the other thing we can take a look at is the specific gravity of a battery. So earlier we looked at the H2SO4 in water. We know that there's 36% H2SO4, and with that it gives us what we call a specific gravity. How dense is that fluid? Well, with the density of the fluid, as the battery starts to lose power, as the voltage starts to drop, the H2SO4, or the SO4, attaches to the plates, which increases our water level, which our specific gravity is then going to drop. Now, we're going to use a hydrometer to detect the specific gravity of a battery. There's a couple different types of hydrometers that are out there. Some are self-compensating for temperature, some aren't. So if the temperature is higher, we may have to adjust for the temperature. That's why it's always nice to have one that's self-adjusting. Be very careful when we're taking the sulfuric acid out, that when we go to put it back in, we don't spray it back in because it can come out and all over our clothes. Now, we talked about maintenance-free batteries again. If we have a green dot, dark dot, or a clear dot, make sure you understand what those mean. And when we're hooking up to test a battery, make sure that we hook it up properly. We have to have a good connection on these posts, otherwise we're going to get arcing and sparking inside, which can cause a problem, especially in any of the threaded areas. Now we're going to take a look at load testing. So load testing is going to tell us how good our battery is. Now there's a couple different types of load tests that we can do. We can do what's called a resistance test, but we're going to take a look at first at doing a load test. So what do we need to know? Well, we need to know what the voltage of the battery is. Any battery that's below 12.2 volts, we should be charging it up before we load test it. There's no point trying to load test a partially dead battery. It's going to fail. So on our load tester, we have a voltmeter, we have an amp meter. Now the amp meter is going to tell us what the current flow is as we load down the carbon pile. And we're loading down the carbon pile to create a load in the circuit. And what we want to watch for is what does the battery voltage drop to as we're load testing a battery. So how do we hook it up? Well, most load testers are now compact. They're all digital. So what we're going to do is we're going to hook the positive to the positive, the negative to the negative, and then we're going to take an amp clamp and we're going to hook it to the positive side of the battery cable. Now when you take a look at the amp clamp will have an arrow on it, and that is the direction of flow of current. So the current is going to be flowing out of the positive side and going to the negative side. So we want the arrow pointing away from the battery. So once that's hooked up, we're going to take a look at, number one, what is our voltage? You know, let's just say we've tested our voltage is 12.6 volts. All of our tests that we're going to do, we're going to load them down for 15 seconds. So 15 seconds is what we want to know. So we're going to load our battery down. So going back to our load tester, we're going to turn our carbon pile, and what we're going to do is we're going to load it down. So let's just say that our battery is 1000 CCA rating. We're going to load this down. We're going to turn this carbon pile until this comes up to half the CCA rating. So 500 cold cranking amps. We're going to do that for 15 seconds. Now the new load testers will have a little buzzer on them that will count. As soon as you start loading it, it starts to count. And at 15 seconds, what we want to do is we want to see what our voltmeter reads. Our voltmeter, we want it to be above 9.6 volts. So what happens if our battery voltage is below 9.6 volts? Well, that doesn't mean the battery is bad. But what we want to do then is we want to put the battery on a fast charge. So we're going to take our battery charger and we're going to hook it up to the battery. And what we're going to do is we're going to fast charge the battery at 40 amps for 3 minutes. And what we're going to do is we're going to watch our voltage. We're going to have a voltmeter across there and we're going to watch to see what happens to our battery. Now, our battery voltage should stay fairly low, but if our battery voltage starts to climb, it could indicate that we have a sulfated battery. Now, if we have a sulfated battery, we can take that battery and we can put it on a trickle charge, a slow charge, and what will happen is it'll break up the sulfate. Remember, the sulfate is what attaches to the negative and positive plates and prevents that flow of electrons from flowing through when we connect our negative and positive. So if we can break that sulfate up, then we can increase that capacity of that plate. So sometimes it may take a couple days to break the sulfate up, especially if that battery's been sitting dead for a long period of time. So that's what we want to watch for. The other thing we want to watch for is we want to watch for temperature. We don't want the battery to get too hot. So this is why, again, when we fast charge it, we want to check the voltage, but we also want to watch the temperature. Now, once we have finished, let's just say that everything worked out right. We've finished our fast charge. We've done it for 3 minutes, and our battery voltage is going to be up, say 13 volts. Well, we don't want to load test it with 13 volts. So what we're going to do is we're going to remove what's called a surface charge. The surface charge is an excess charge that was put in there when we set it up to charge it. So what we want to do is, we're back to our 1000 CCA battery. We want to load that battery down at 300 amps for 15 seconds. And that will remove our surface charge off the battery. And then what we want to do is we want to leave the battery for approximately 3 to 5 minutes to let everything inside the battery stabilize. Because we charged it very quickly, created a lot of disturbance inside, then we discharged it very quickly, created more. We want to let that battery stabilize. So after 3 to 5 minutes, we can go back in and we can load test it again. And again, load testing on a 1000 CCA battery would be half the CCA ratings for 15 seconds, and we want to watch the voltage to make sure that it does not drop below 9.6 volts. Now, if it does drop below 9.6 volts, a couple things. The battery can be put on a slow charge and left for a while on a slow charge, or it can be replaced. If it fails the second time again, we don't want to put it into service. We want to do something with it. Some companies will have battery rooms where that battery will go in the battery room. It'll be put on the trickle charger for a few days to try and bring it up to full charge. When we fast charge a battery, we can never get it up to 100%. Maximum it usually gets up to is around 75. If we put it on a trickle charger, the trickle charger will bring that battery up to 100% of its capacity. So once that's done, we can load test it again. So we leave it on the trickle charger for a few days, load test it again. If it fails that time, then the battery can go into recycling. But it could pass. In that case, then it could be put back into service. Again, when we're removing the battery clamps on a post, don't pry on them, because we can break the post off internally and we'll never know. So what they have is they have a puller. We can undo the bolt, put the puller on, and pull the clamp off. And if you take a look at the battery post itself, the battery posts are tapered. So it doesn't take much once we undo the clamp to get it to move. Never put a screwdriver underneath and pry it off. When we're putting our battery post back on, there's a special tool that will expand the clamp so that it goes down all the way. We don't want it sitting up, and the reason for that is we want full contact. The more contact we have with the clamp to the post, the more current we can put through there, because the more contact area we have. What about cleaning and doing maintenance on a battery? Well, if it's a maintenance style battery, we're going to be checking the electrolyte level. Now, we never add sulfuric acid to a battery. We're going to add distilled water only. And the reason we want to use distilled water is because distilled water has no mineral particles in it. If we have mineral particles in and we put it inside with the electrolyte, those minerals can actually conduct current, and it can drain a battery down faster. So we don't want that. So distilled water only. Now, what about cleaning battery posts? Well, everybody has their preference on how they want to do it. Me personally, I don't use one that has a little wire brush. I have one that has a little cutter on there so that I get a nice smooth finish. But however you want to do it, as long as we clean them properly so we get full contact. We want to get rid of any corrosion that are on the posts, and we want to clean the top of the battery. If you take a look and take a meter and put it from the positive post to somewhere on the top of the battery and it has some dirt or something like that, you may see a parasitic draw on that battery. And over a period of time that can drain that battery down. So we want to wash the battery down. If it's a maintenance style battery, we want to make sure that once all our caps are on, for one thing, is because we don't want anything going into those cells that can damage them. We want to wash the top of our battery off, and then we want to dry it, make sure it's clean. We want to clean our battery post, we want to put our connectors back on, and then we want to put some type of a spray sealer on the negative and positive posts, and this prevents any moisture from getting in. So what does moisture do? Well, if moisture can get between the clamp and the post, it will prevent the contact and it could cause a problem. When we're dealing with hydraulics, we talked about where there's a problem we generate heat. Electrical is the same way. If we have a problem with a ground circuit or a power circuit, it's trying to squeeze that current through a smaller wire, and by doing that it's going to generate heat. So if we have a problem, we can just feel along the wire, and wherever the most amount of heat is the bad spot. So always look for something like that. So we want to always make sure that our connections are proper and clean and dry and tight. As we have a loose connection, it's going to create a problem, and current can't flow through a loose connection, and we're going to end up with an issue. Side terminals. Again, on some of these side terminals, we have to make sure that they're nice and clean and free of any corrosion before we put them back together again, and make sure that we tighten them properly so that we get 100% contact. Now, a battery that's stored at 95 degrees Fahrenheit or 35 degrees Celsius will self-discharge twice as fast than one that's stored at 75. So we don't want the battery freezing, but again, we don't want it so that it's too hot. Now, a battery will self-discharge at 0.2% per day just by leaving it sitting there. So you think about it, you leave a battery for a month, how much of it has self-discharged? Now, the other thing is, with now that we have all these electronic components in a vehicle, some of these will draw. There will be a parasitic draw from that battery over a period of time for running, keeping the radio or security systems going. So if we leave a vehicle unattended for 2 months, it could drain the battery down just from these extra safety, or these extra units running in the background. So what happens internally inside a battery when we have a problem? Well, a short. And when we're dealing with electrical, there's three things. Opens, grounds, and shorts are what we have for problems. So a short in a cell is just a shorter path for current to flow. So again, within each cell we have a number of negative and positive plates. So a short in that cell means that it's a shorter path from going from negative, positive to get to the positive end. It's just a shorter path. What that does in that cell is makes part of that cell inactive. It can't produce the current. So again, each cell is capable of producing 2.1 volts. If we have a short, maybe that cell can only produce 2 volts, or maybe it can only produce 1 volt. Well, overall in that battery, we've just lost 1.2 volts possibly. Well, that will bring the capacity of that battery way down. So we got to pay attention to that. And again, will that show up? Definitely when we start to do a test. So electrical loads on a system. So for instance, one of the places I worked, they would shut the forklift down and restart it probably 200 times a day. Well, between the startup and shutdown was never long enough to recharge the battery. So by the end of the day, the battery was depleted because it could never be brought back up to full charge. So we always want to make sure that the capacity of our battery can meet the needs of the system that we are running. We have a small capacity battery, and we have a large stereo, and we have air conditioning, we have lights, all these extra lights on a vehicle. Well, it could conceivably exceed what the output of the generator is, or the alternator, and we can never replenish that battery to full charge. And over a period of time, that battery every day, if it's never getting a full charge, could start to create problems. Now, some of the other issues we want to take a look in a battery. We've already talked about a short, but over a period of time, we have a battery that's, say it's been running on rough roads. Over a period of time, the shock load inside can cause some of the plates to start to break apart. And again, just like a short, that plate now is ineffective because it's not part of the circuit anymore. When we have problems internally, again, where parts of a plate are broken off, creating a short, or if we have a plate that's open, and open is no contact. So if we have contact, it's a closed circuit. If we break it, that's an open circuit. Now, if we have an open circuit between the positive plate on one cell and the negative plate on the other cell, when we go and do an open circuit voltage, it will read 0 because we don't have any potential difference because there is an open in that circuit. It's like having the switch turned to the off position. Now, we've talked about exploding batteries, and I've seen a couple myself. We had one in our shop where they were charging a battery and they tried to start the vehicle at the same time. Now again, as we're charging a vehicle, what happens? Internally, we get hydrogen gas that's given off. If we take water, H2O, we can break it down into hydrogen and oxygen. So as a battery is charging, the hydrogen's giving off, and what happened is there was an internal short that blew up the battery. I also worked with a guy that had a wrench in his pocket. He leaned over and the wrench fell out and crossed the negative and the positive of a 24-volt battery, and the battery blew up in his face. Lucky for him, the case came up as a single unit and he didn't get sprayed with sulfuric acid. So always pay attention to what's going on when we're working around a battery. If, for instance, we see that it's a clear eye on a maintenance-free battery, don't try and charge it because we run the risk of it exploding on us. What about when we're jump-starting a vehicle? So, again, what do we connect first and what do we connect last? Well, first thing we want to connect is the positive of discharge battery, and this is assuming that we have a negative ground battery. So number one, we hook up the discharge battery positive. Number two is the booster battery positive. Number three is the negative of the booster battery. And number four is a good ground. Now, on some of the vehicles, they'll tell you to hook it up to the negative of the discharged battery. Now, then what we want to do is we want to start the vehicle, or if it's not already started, and we want to, before we try and start the vehicle that's got the dead battery, we want to allow it to charge for 5 to 10 minutes to allow some capacity to get back in that dead battery. Now when we're finished, we want to disconnect it in the opposite order. But what about What if we have a positive ground vehicle? How do we hook up the battery posts on those? So think about it. If we've got a negative ground vehicle and a positive ground vehicle, how do we charge it? So a battery is a battery. Positive, positive, negative is negative. We still hook up positive to positive and negative to negative. One of the things we really have to be aware of is don't let the vehicles touch. If we have metal to metal contact, we're going to short something out and something's going to blow up. So again, be aware of what we can and cannot do. So for instance, how do I charge a battery when I can't reach the battery? Well, if it's a negative ground system, we have two negative ground systems, we can actually move a vehicle up, and I've had to do this in the bush, where he parked it off the road one night and left everything turned on. Get there in the morning and the battery was dead. Well, I had a long set of jumper cables, but I couldn't use the jumper cables to hook the negative to positive. So what I did is I hooked the jumper cables together, and I moved my service truck up, and I touched the frame of the machine with my metal bumper, which created the ground side. And then I just hooked up positive to positive, and that completed the circuit and allowed the battery to charge. So again, understanding how these systems work is really going to help you to troubleshoot. And again, our job is to get these vehicles going, get them back on the road. So whatever it takes. Sometimes little ideas like that will work. So what about charging batteries in series? This is something I've never done. But what we want to do, again, we talked about slow charging. This is the more common way that we're going to charge a battery. We're going to charge them in parallel. So parallel is positive to positive to positive and negative to negative to negative, where when we're dealing with series, we're going positive out of our negative to the positive of the next one, out of the negative of that one to the positive of that one. But what this does for our voltage is, if these are 312 volt batteries, that's 36 volts. But when we deal with this style here, positive to positive to positive, this still gives us 12 volts. So in a vehicle, we might see 4 12 volt batteries all hooked in parallel to still give us 12 volts, but it increases our CCA rating. So if each battery was 1,000 cold cranking amps, and we had 4 batteries that were in parallel, we would have 4,000 CCAs. Now, if we had 4 that were, 2 were in series with each other, so we have 22 sets of 24s, our CCA rating of each set would be 2,000, but our maximum of the 4 batteries would still only be 2,000. Okay, so reserve capacity, state of charge, and again, understanding what series and parallel circuits are. Series circuits, so off of the positive goes to, let's just say, our starter. The negative that hooks to the positive of the next battery, and then from the negative of that battery to ground. That is going to give us a series circuit, which is going to increase our voltage. So if these are two 12 volt batteries, our battery voltage here is going to be 24 volts. These are 1200 CCA ratings, and that's not going to change our CCA rating. We're still going to have 1200 cold cranking amps. But if we take that and we hook up these again in parallel, where positive is hooked to positive and negative is hooked to negative, our voltage stays the same, but our CCA rating increases. Now, a truck coming from the factory that's made down south, they don't need the battery capacity that we need, So they may only come with 2 batteries, which we may find that in the wintertime it's not enough to get a cold truck started. So we may have to increase that and put 2 more batteries in. And what we're going to do is we're going to run them in parallel. Now, one of the big things is we have to make sure that our battery cables are capable of handling the current that's required to get a vehicle going. So it's really important. There is a chart out there that will tell you the length of a battery cable and the capacity that it can handle in amps. So taking just a quick look at how some of the batteries are set up. So we can see that this is a 6-volt battery and another 12-volt battery, another 12-volt battery, because it has 6 cells on it. But when we take a look at the cables, we can see that the negative of one cable is hooked to the positive of the other. So we know that this is a series circuit. If these are 2 12-volt batteries, this is a 24-volt starting system. When we take a look again at this style here, it may be a little hard to see, but all the negatives are hooked together and all the positives are hooked together to give us 12 volts, but increase our CCA rating. And that's it for batteries.